All right, we're going to continue the review. I'm going to look at slope now, determining slope. So we're going to look at several of these. So question number 14 on mine gave me a graph, and they had a bold dot right up here, and then another one over here. Okay, and they had the line and everything sitting there. And the question was, find the slope. Find the slope. Okay, so they don't want the equation, they just want the slope. They just want to know the m value. So when I'm looking at a graph, I like to think of the slope as being rise over run. And I basically just count to determine my slope. I start with my leftmost point and I determine how far up or down I would need to go to get to my next point. So I'd have to go down 2 units. That's the rise, down 2, okay? All right, and if it's down, or if you had to go to the left, you would have a negative on it. All right, and then the run would be to the right, 1, 2, 3, 4, 5 spots. So I'm going to put a 5 down there. And then at that point, you would simplify if you needed to simplify, but this is actually completely simplified. And so that's all they want. That's what you would put in the blank. Okay, they want the answer as a fraction or an integer. Don't put it in as a decimal. All right. Number 16 is the next one I thought we'd look at, and that one asked me for slope, but it gives me 2 points. Okay, so here's the 2 points I had in my problem number 16. So when that happens, I go to the formula sheet, or I just think about what slope really is, and I just look at my formula sheet. And so the formula sheet is trying to tell me that the slope is the change in the y's. This is how I really think about it. The change in the y coordinates over the change in the x coordinates. Okay. And so I don't really obsess about the x2, x1 and all of that. I just make sure that when I set things up, that I subtract my y coordinates and that's on top. Doesn't really matter whether I say 4 minus 8. Like if somebody said 4 minus 8, you would also be correct. You have y coordinates and you've subtracted them. Okay, so these are your y's. And then make sure that when you subtract your x's that you're consistent and you do them in the same order. So if I started with the 8, then I need to start with the -4 on this one. And I would do -4. This is harder because of all the negatives. Minus a -3. These minuses are part of the formula. And then the coordinates themselves might turn out to be positive or negative. Those of you who might have set up the top as 4 minus 8, you'd get the same answer ultimately, but your denominator should be -3 minus -4. Should be the reverse of what I did. And then let's see what happens when we simplify those. So I got my y's on top, and these came from the same point. That's what I look for to check before I get started. Those come from the same point, and these are y's. Because that's basically what the subscripts are trying to do. They're trying to tell you, did you subtract in the correct order? And that's what looking at the 8 and the -4 and making sure they came from the same point. And then just double checking that you put the y's on top and the x's on the bottom. All right, so 8 minus 4 turns out to be 4. Now the denominators are a little harder because of all the negatives. It's -4 minus -3. That's -4 plus 3, so I get a -1. And then don't type it in like that. Even though I know when you're graphing, it's good to have the fraction. The fully simplified version of that would be -4, and that's what should go in the box. Now we'll get a -4 on this one as well, but the numerator is -4, and the denominator turns out to be +1, but that would reduce to be -4. Okay, so either way you set it up, either of these, okay, like that or like that, it's going to give you the correct answer. And they just wanted slope, so you stop at that point. Okay. All right, now one other way they could ask you to get slope, remember, is by giving you an equation. All right, and this line right here, this is standard form. Standard, I didn't spell that right. Try that again. Standard form. Okay, what they're wanting you to do is look at that equation and determine the slope. So your plan should be, you need to solve for the y. This is kind of like what we did in chapter 2 in section 2.5. Solve for the y, okay? So we're going to take that equation and we're going to work on getting the y so it's by itself, because if I can do that, I'm wanting to get the equation so it looks like y equals mx plus b. That puts it in what we call slope-intercept form. And if I can get it in slope-intercept form, all I have to do is look at what's in front of the x. Don't make the mistake in saying the slope of this line is 6, because it's not. Okay, so I'm going to subtract the 6x. That would be negative 5y equals negative 6x plus 10. You should not be thinking that you can put 10 and negative 6x together. That was chapter 1 material. Those are not like terms, okay? So you would be to here. Then you're going to come in and divide by negative 5. And that negative 5 has to get distributed. You're really doing this. You are just doing this. But then since that fraction bar goes underneath both, you have to distribute that negative 5 into both parts. So you would go ahead and do that. All right. So then what happens is the negative 5 you divided by, because that would get you the y by itself. Here, a negative divided by a negative would be positive 6/5. And 10 divided by negative 5 would be negative 2. So we can just write minus 2. But we don't really even need the minus 2, right? Because this problem was find the slope. The question on number 16 was find the slope only. And so once you do that, you can say, okay, that's my slope. M equals 6/5. This is your answer. Okay, so that's how you would get the slope if you're given an equation. All right, I'm going to do number 20, but I'm going to wait until later to do that one. I wanted to go ahead and look at graphing using the slope. So let's look at 21. Okay, so here's a problem where they gave me an equation, they asked me to graph it. All right, so we've done that already by plotting points. So this is by plotting points. Okay, if you were thinking, oh, I'm just going to do a table of values, I'm going to pick some things for x and see what y is. Okay, that works. But they didn't want us to do that. They said to graph by using the slope and the y-intercept. All right. And the reason they're asking you to do that is because it's a very effective way of graphing this. So if we're trying to graph using the slope and the y-intercept, we make sure the y is on a side by itself, which it is. Then we can identify the slope and the y-intercept. Okay, so m equals 2, that's the slope. Okay. The b is 5, and it is positive 5. See how that's a plus, so it is 5. If that had been a minus, you would have said negative 5, but it is a plus. And that b value is the ordered pair 0, 5, which is the y-intercept. So if the equation is already in slope-intercept form, you have the slope and you have the b, so take advantage of it. And the little way of remembering what to do is I was talking about using the b to begin and the m to move. So I'm going to begin at 5. Always, always, always on the y. Always, always, always begin on y when you're graphing a line where you've got the equation. Okay. All right, so I'm going to begin there. All right, now, what I'm talking about when it says, when I say move, is the slope. You should think of it. The y-intercept is a specific location, like a house. The slope is actually the directions for getting to another location. It helps to have it as a fraction because what you want to think about is the rise over run version of the definition for slope. So the 2 means go up 2 because it's the rise and it's positive. The 1 is the run, so you're going to go to the right 1. So what you're going to do is from that point, you're going to go up 2 more. Okay, you're going to go up 2 more units and to the right 1, and then have a point. You could do that multiple times if you're doing it by hand. Okay, and then your line would be that line. Okay, that would have up 2 over 1, up 2 over 1. Okay, you also could go down 2 and to the left 1, okay, to get to a point on the line. Okay, so when you're graphing using the slope, it's a great way to graph. Let me do one more on that same graph. I'll do it in green. Let's do it in green. Suppose you have y equals negative 1/3 x plus 4. Okay, so the m is negative 1/3 and the b is 4. So I'm going to begin at 4. The slope is already a fraction and it's negative, so let me make sure I put the negative in one spot or the other and then interpret it correctly. So I would go down 1 and to the right 3. So from there, I'm going to go down 1 and then I'm going to go to the right 1, 2, 3 to get to another point on the line. And there you have it. Okay, see how that line had a negative slope? The line should be falling, correct, as you look from left to right. And remember how this one had a slope of 2? See how it's steeper and it's rising? This one had a slope of negative 1/3. So it's falling as you look from left to right, and it's flatter than the other line. Okay. All right, so those questions all involved slope. All right, let's do one more on this video. Okay. All right, so the next one I want to do is number 23. Here they're asking us to graph, but it's kind of a strange question. It says graph the line passing through. And it's passing through the point 1, 4. And then it says, and having the given slope. Okay. And the slope is undefined. Okay. So 0.14, slope undefined. All right. So let me think. All right. So well, I know it has to go through this point. So let me plot that 0.14. Okay. Now, to do what that undefined slope means, I want you to think about how you know it's one of these two, and the undefined went with the one that you couldn't climb on, you couldn't walk up. So from there, you're going to want to draw the line that's straight up and down. Okay. All right. By the way, if they had asked me for the equation, what if you needed the equation, which you might later, I could now look at that and see this was the 0.14 and the line has to go up and down. See how that makes all the x's equal to 1? Okay, but that wasn't this question. This question just wanted you to graph. All right, I want to go back to the assignment because some people have trouble using the graphing tool on this. And so let me make sure you can do that. Okay, that's not where I need to be. Let's see. Okay. Get back in that assignment. So weird. All right, so let me go back in that assignment. And I want to go here to the review. Let me just preview it. Bear with me for just a minute. I got off of it. I was posting some things for you. Okay, so let me go in and review. Okay. There we are. And I want to preview that. And I want to look at using the tool on number 23 with you. Okay. All right, so let me get over to 23. Because sometimes on this one, I noticed people kind of have the idea, but they're not sure what to do on the tool because it's a little strange. So with this one, this is a little different than the one I gave you an example of. This one said the 0.35, so I'm going to plot the oops, I need to pull that point up. Let me just clear that. I was using my tool instead of the cursor. Okay, let me just start over. So I'm going to plot the point 3, 5. So I go to that spot and click. And then if I want the line to be undefined, I have to drag to go to another point. And the point needs to be up or down. It doesn't need to be in a certain location, just anywhere up or down from there. Okay, then I'm going to save that. And that's what they're looking for. Okay, you see? All right, now let me go back and see if we got through the stuff I wanted to get through on that. Yeah. All right, so that section of problems, that deals with finding slope, graphing using slope, okay? So I'm going to stop this video and post